We are ready.
Okay. So today I'd like to talk about an Edge project called the KubeEdge we worked on at Huawei. So for this project, we have two topics accepted by KubeCon at Shanghai this November. So as I mentioned, I'd like to share the ideas and the couple of POC use case and how Huawei view the edge cloud and the high-level architectural design, especially for how we use Kubernetes at edge. Feel free to interrupt me anytime with questions or comments. Yeah. Can you move to the next? You know, like artificial intelligence nowadays is a hot topic. And AI at the edge can enable a lot of possibilities, such as municipal security and smart city. I'm sure all of you have used the ticketing system at a parking lot. It requires a person to manually acquire and verify the ticket. Oftentimes at a busy time, people are frustrated to find a parking lot or a vacant spot at a gas station. For example, the below picture, you can see a dashboard at Costco gas station. So what I want to say, the scenario is with image recognition or intelligent video camera installed at those public places, they can enable a lot of things. As I mentioned for the first scenario, the car and the driver can be recognized automatically and with actions taken. And then for the second, for the parking lot or the gas station, the cars, their locations, all the data can be collected, analyzed, so that a lot of things are guidance, a simple guidance board can be shared to the audience and then enable a lot of efficient actions. Then drill down all the two scenarios. We found out the below functionalities. Like we need to, as a user, I need to register or configure the edge or the things at the cloud. And then a user need to configure, deploy the image recognition AI model or serverless functions from a cloud to edge. On the other hand, the functions would need to be scheduled, triggered upon conditions on the edge. Furthermore, all the image data can be collected and streamed from the edge to the cloud for advanced analysis. We need to move to the next slide. So here is a real customer scenario. We worked with a customer in China. It's about a water tank system in a city. Okay, as you can see, there are A, B, C, 3 water tanks geolocated at different locations in the city. And then for each water tank, there is the edge node, the sensors and valves installed. Among all the edges, they are aware of each other. So they can, from a network perspective, they can communicate with each other. For example, water tank A can broadcast its water level to the other water tanks. As a whole, the system can intelligently decide how much the valves need to be open or closed so that the whole system is efficient and prevent like water hammer, those kind of things. So some details is like they need network communication among the water tanks. The whole system is decentralized in the sense, in case there's no network connection between edge to the cloud, the system can autonomously work effectively. And local, quick, in case of, for example, I mentioned the water hammer scenario, actions can be taken really quick and reliably. So this is, and on the other hand, from a cloud perspective, admin for the whole water tank system, they can monitor the health for the whole system. So this is another scenario. Next. So I'd like to share how Huawei is viewing the edge. As you can see, cloud is in the data center. Then we have the edge nodes, and then the things, a lot of IoT devices. We see edge is an extension of cloud. The edge nodes are located at edge, but they are managed and registered from the cloud. Applications or serverless functions are orchestrated and deployed from cloud to the edge. So this is, as we see, it's a cloud extension. And then between the edge and the cloud, there need to be bidirectional network communication. The communication sometimes for the edge, it has its own private network, and then we need to make sure the bidirectional communication is enabled. Secondly, the network connection is not reliable. Sometimes the edge can be offline, and then we need to handle that. The third will be, there will be large scale of edge. So we need to make sure the cloud has the sufficient bandwidth to handle all those. Thirdly, we see the edge and cloud need to be loosely coupled. As you can see, the water tank system, they want the edge nodes can be autonomously manage them, work, if run themselves, local, quick, and reliable. On the other hand, a decentralized system, the edge and edge can communicate with each other without even being managed by the cloud. Okay, so lastly but not least, so the edge node itself can be heterogeneous. It can be a regular server machine or resource-constrained Raspberry Pi. And then the edge itself would need to support, again, a large scale of IoT things. And between the thing and the edge, there can be multiple communication protocols.
So am I taking questions now, or should I wait till the end?
Anytime.
Okay. So just a comment on the heading for that last one where it says heterogeneous. I think you mean non-heterogeneous then, right? So you're implying that the central could be, say, x86, and then the edge locations, if they're Pis, would be ARM processors or something? Okay.
Or even have a GPU.
All right. And then by different communication protocols, you mean like non-TCP?
Yes, like MQTT or I think like a...
Okay, I got it.
Yeah.
And then for edge-to-edge awareness, does that imply that two edge locations at different sites can talk to each other, potentially even when the central location is down, and that they discover themselves?
Yes. Yeah.
Okay, I got it. Thanks.
Okay. Yeah. What I mean is the edge nodes, the machines can be different architecture, heterogeneous, or even involve GPUs, or they have different scale settings. But we, as a goal, we like to make sure our system could generically enough and cover all the scenarios.
So how far down in terms of processor do you envision these going? You know, down to say 8-bit CPUs and really small things running non-Linux operating systems, or are you at least constraining this to be Linux everywhere?
That's an excellent question. So I think from OS perspective, right now we are targeting Linux, But I know like for Amazon AWS is supporting free RTOS, but it's still Linux based. And for Microsoft is exploring Windows. I think the system, like for Kubernetes, it's supporting any architecture. It's just a kind of execution work. The architecture would allow that. It's just time or how we enable it. And then the GPU, all those things can be included as well. I believe Kubernetes supports that as well.
Okay, and then for network, I know you said it didn't necessarily have to be TCP, but is that uniform, or are you picturing a mixture of, say, classic internet plus cell networks?
Okay, so from an edge to cloud perspective, it still need to be internet, TCP or HTTP. But between the edge and IoT, it can be different protocols. So then the gateways need to be, or the brokers need to be available to support all those.
Okay, thanks.
Mm-hmm.
So in this case, I see the picture on the right side. So are your architecture supporting both connecting things directly to the cloud, that simple connection, and with the edge, or is it a transition from the one to the other?
Yeah, okay. So for the open source project, the KubeEdge we are sharing in KubeCon, we are targeting the second one. But as a Huawei production, we do plan to support the first one as well. Yes.
So together, working together.
Yes. Yeah.
Okay. Okay. Thanks.
Okay. So next, we can move, right? Okay. Okay. So here I'm just sharing a very simple version of the whole architecture design. And also like to share a vision we see about this KubeEdge project. Is we want to see everything is just like you work on a Kubernetes cluster. Even the resources are located, the edge node is located remote. And then we have a special component, we call it KubeBus or KubeEdge bus. This one enables all the communications, bidirectional and multiplex communication, TCP communication between the edge node and the cloud. And even like in production, we support like between edge to edge as well.
Is the edge controller there a Kubernetes controller? Like it's a custom, okay, it's a custom resource controller?
Yeah. So I personally wrote the edge controller. So the point is to address the loosely coupled scenario because, like nowadays when we use Kubernetes, kubelet needs to, every 10 or 30 seconds need to report a heartbeat to the Kubernetes API server.
Mm-hmm.
And then, as I mentioned, the edge node can be offline as well. So that's why we designed this edge controller so that it can store all the customer requirements, like pod spec to a storage. And then this storage can be synced down to the edge node based on the network connection. And so that it can store it locally on the edge, and then the edge can be autonomously take action.
And the so this is a fascinating slide. Hopefully we can maybe kind of talk through some of the details on it. How does that edge controller compare to the virtual kubelet idea? Does it represent, how does it represent the edge in the master control plane? Is it just a custom resource, or is it actually a proper node?
It's a proper node. It's still the same. So it just hide all the, from a concept perspective, it's similar to the virtual kubelet, though all the edge, each edge node is represent a single Kubernetes node. We don't like hide anything there. So each individual node will be a single node here in Kubernetes API server. And
so there's a second, there's like another arrow to the control plane, which is the standard kubelet to master connection, in addition to the sync service, or?
Yeah, okay. So okay. So the app engine is a revision of kubelet we wrote. So this app engine can take all the pod spec information and do things locally. Another point is we want this app engine to be lightweight, because as much as possible, kubelet has a lot of functionalities we may not need it in the edge scenario. So we modified it and then it can take action. The other hand is, as similar to kubelet, it can do the flag actions and report all the node and pod status back through the sync service to the API Kubernetes cluster.
So is this essentially like running static pods, where, you know, a static pod is one where the definition of the pod resides locally? Okay.
I think it's different, okay? Because for static pod, there's a shadow or mirror in the Kubernetes API server. We don't do that. Customer can still dynamically put in their pod spec, and then we just regularly make sure they're synced down. And then in offline scenarios, things will work locally.
So I'm also interested then in how the container images get pushed down. Are these held in an image repository that's centrally managed and then pushed to the edge locations? And then what that implies, which is interesting, is that since you're non-homogeneous, meaning the images that would run at central are likely x86, but the ones at the edge could be ARM. And mixing those in an image repository is something that I'm not sure has commonly been done. Have you guys got a prototype like that working?
Yes, yeah, we do. So the thing is, back to your question is, you know, we use kubectl to register the device, right? And then all the metadata is stored here and here, right? So then when the edge node pull down the images, it knows what to pull down.
Okay.
What kind of like architecture or like there's, so.
Is it using Docker pull though, or is it doing a different kind of pull down?
It's using similar to Docker, like the CR. Basically, we use the OCI. We follow the OCI protocol. Yeah.
And then at the central, then can the central still monitor what images are running and pull off, say, rolling updates and things like that?
So for the rolling update, we haven't tried yet, but you know, like from a monitoring perspective, using kubectl, people can just do what we are currently be able to do, like you query the node status or pod status. So the philosophy or principle we are trying to maintain is like, even at the edge scenario, we are working as like a normal cluster. Things are still continue working.
Can I ask you, is this open sourced? And if so, could I get a link to the repo?
So that's we plan to open source, but you know, like we are still working on it. So the target is like for the KubeCon, we plan to announce it and share the.
Well, I don't care if you're still working on it. If you are going to open source it, I'm curious to look at it now, whether it works reliably.
Can I know who's talking?
Steve Wong from VMware.
Okay.
Yeah. And this is Preston from Google. I think a number of us on this call would be, you know, as the Edge working group folks here who kind of show up regularly, we'd all love to see it. I see there's a KubeEdge org and repo on GitHub that seems like, is that the placeholder for it?
Yes. Yeah, but we are not open. We haven't opened it yet.
Right, right. I just see it kind of like a, putting the flag in the, the ground.
Yeah. Yeah.
Yeah, I mean, I think there's a lot of, there's a lot of meat in what we could discuss around like the nature of the way that controller is representing the resource and how the container content is pulled. Things like Stephen mentioned around like, do you use, I guess the biggest overall question is sort of how and where have you needed to deviate from what Kubernetes does as sort of default concepts in order to achieve the functional goals you needed? And are there any of those places that could, essentially be turned into features in Kubernetes itself rather than kind of custom adjacent code? That's kind of my intriguing overall question.
I think that's an excellent point. Personally, from a pod spec or config map or secret, all those kind of thing perspective, while I'm implementing the Edge controller, I don't see Kubernetes lacking any capabilities. So the only challenge is around the service endpoint concept.
Cluster IPs and stuff like that.
Yes, because we, like in the Edge scenario, as I mentioned, the Edge node can be in a private network. How can we ensure that bidirectional network communication is the biggest challenge? And then that's why we enable the bus. And then on top of that, how can we enable the service endpoint service and allow customer to like just deploy application, then use service to enable the service discovery. That's one thing I don't see. I think Kubernetes, some features we need to do here.
Can you talk a little bit more about the bus?
Yeah, that was my question.
Yeah, or in this diagram, it looks like there's two buses. Are those independent networks that?
Or is this like essentially like a tunnel, like a reverse tunnel, so that the edge can communicate with the master as if it were?
So those are two services running, one on the edge and one on the cloud. And then like we follow the I forgot the exact name, the network layers, like level 2, 3, and 4 or 7. We re-implemented each level and then ensure the bidirectional network connection. So the point is to enable a multiplex with a single connection between one node and a cloud. It can be multiplexed and then bidirectional.
Can you, I mean, can you say anything more like about the specifics of that, the networking layers? I mean, is it, or is there another, maybe we can.
Maybe we can like book this and then we can talk in detail next, because I'm personally, I like we work as we have a team here, right? I own the Edge controller, and one of my colleagues or two, they work on the bus design. So yeah.
So let's say you have 100 sites. Are there 100 different Cube buses, edge networks?
Yeah.
Or are they all unified?
So I'm not sure if I get your question. So the point is, on the cloud, there's only one Kube bus service, or like it can be scaled, okay?
Right,
and then
but on the edges, like if I have more than, your diagram shows one edge location, but if I had two, is that two Cube bus at edges, or is it one that where it's a network where they all see each other on the same subnet?
No. So for the multiple edge node scenario, each edge node will be the same. Like they will each has a Kube bus service.
Okay, I got it. Thanks.
Node.
Yeah, and I know maybe feel free again to deflect this until we have the person who maybe can answer. But if, from your understanding, is the idea of the bus to provide something that is at the kind of logical message layer in terms of, you know, discrete controller messages, or is it to provide something that is more of a network layer, like pass through for being able to kind of reach arbitrary kind of cluster IPs or that kind of thing?
It's similar. It's a network overlay.
Okay, so it does go down to the ability to sort of say, I need to reach like a Kubernetes service running in the cloud by a cluster IP address. It'll route that.
Yeah,
okay.
Exactly. Enabled all the service discovery and routing.
Okay, so it's kind of like a VPN, basically.
Yeah.
To some degree. Okay.
Yes. Yeah.
And then at a higher level in the network stack, do you envision providing a service with message queuing so that if connectivity to the central is temporarily out, attempts to send things up would be queued rather than having to take that on inside applications?
So the idea is either like a queue, or we have a storage local at the edge and on the cloud, right? So in case of offline, it's disconnected. Once the connection is rebuilt, then the two storage can be synced through the sync service.
And this is great stuff, by the way. So I just have a ton of questions. But the Metastore, what are you guys using as a backing? Is that just another Kubernetes service with a number of storage plugins, or what is that exactly running to?
So initially, when we prototype, we are using etcd.
Okay, so it's a key value. It's sort of a key value.
Yeah,
so you can adapt it to
non-structural key value pair.
Okay, so you could take it. Are you exposing it from the Edge controller itself? Are you speaking etcd using client etcd libraries directly in the Edge controller, or do you have a small shim running as like a Metastore service that just relays etcd now?
Yeah, good question. So Edge controller is calling the similar to the controller Kubernetes controllers, calling the etcd client APIs. Okay,
so you don't yet have a point of kind of decoupling injected in there.
So Preston, can you help me understand what?
So the idea here, so let's in the situation Stephen's talking about, where you have many of these, or you have maybe other places you're trying to work with metadata about the edges. Instead of relying on etcd for that, if you wanted to swap in some other managed sort of key value system, whether the Edge controller simply had an adjacent, even a sidecar that sort of wrote key values that it needed to in an abstract way, and that thing then would use etcd by default, but could be configured to store those key value pairs in another system, in a way that when you switched it, the Edge controller didn't care that you switched it, right? Because it only knows it's speaking kind of its own API contract to the Metastore system.
So I think maybe I didn't say it very clear. So between here and here, there's a protocol, right? So then as long as the protocol is ensured, then behind the scene, whatever storage, it can be used.
Okay. So there is a contract kind of.
Yes.
But what you're saying, just to be clear, that disk shaped picture down in the Edge core that says Metastore at Edge, you're saying that's an instance of etcd?
So it can be SQLite. Again, it's the same thing. So there's a protocol here. Okay. People can use SQLite or etcd. Here, it can be a queue.
Well, there is one difference in that with etcd, you could conceivably make it a cluster so that you could take a rolling update or something, whereas with SQLite, I think you'd have to take an outage should you ever update it.
The thing is, okay, so here's my personal view. because keep in mind the edge node can be really light, like a memory constraint. So then one has to decide what kind of storage you want to use.
Yeah, you
and
could just use a level DD, right? Like you could use something very light.
Yeah, plus oftentimes like the HA requirement on the edge node is lower than the cloud.
Can you give us an idea of some of the types of things that the Metastore is storing? Like what are some examples of the kind of data you're persisting to provide the controller?
Okay. So the store would store, for example, from a Kubernetes orchestration perspective, it will store the pod spec, like a customer put through the kubectl, and also the node information or the metadata. And then on the other hand, from the App Engine sync back, then through the controller, it also store the pod status and node status, so that like it can report back to the Kubernetes API server.
And you're doing that even though you have potential direct connectivity from a kubelet / App Engine to the master API server itself. What is the, like I'm trying to understand for some of those functions which are normally done just by a node and a kubelet, you have this App Engine which is sort of a derivative of the kubelet, right?
Yes.
And now instead of having that communicate over kind of layer 3 network directly to the API server in the cloud, you're kind of relaying in both directions some similar information through this sort of alternate path. And I'm trying to get a little bit of better understanding of why that's what that's doing differently or better in that case.
Okay. Yeah, I'd like to hear all your thoughts as well. So the main point is to enable the loosely coupled because we assume the edge nodes can be offline and reconnect. On the other hand is for all the data, they are metadata, right? So have some duplicate redundancy, we think it's fine. The other one I want to say is for Kubernetes API server, you don't have in the API server in the etcd tree, you don't have a view of for one node what are the available pod specs, rather than it's a pod spec what are the nodes. So then from a performance perspective, we want to restructure the tree in the Metastore and then make sure then the efficiency between the cloud and edge.
Interesting. So, and just to clarify, like if I were to do a kubectl get nodes and do kind of a listing of nodes from the cloud, I would see all of the edges as well?
Yes, yeah. It will behave as what we have in the cloud.
Have you thought of a scenario where for availability and redundancy, you could have an edge location potentially talk to multiple masters or fail over to a different one?
I think that's a good question. So Steve, I would assume you're thinking of when the edge nodes are large scale, then or like you, as you mentioned, you're thinking about the HA scenario. You want to, because the master, one of the master is not over. Sure, from a cloud perspective, we plan to enable multi-tenant HA capabilities as well, just like what Kubernetes is enabling right now.
Yeah, I just bring it up because in the context of legacy things like SCADA systems that were IoT before they called it IoT, in high value things like pipeline controls, it's not uncommon to have backup supervised.
I'm not sure if only me or not. Your
No, I'm
voice?
hearing it too. I don't know
Yeah,
whose
same
microphone is
here.
maybe doing that.
Okay. Okay. So I think the other one is can we rephrase or repeat what we talked earlier? I think Preston asked me about what features Kubernetes is lacking after we enable this architecture. So we talked about the Kubernetes service, and then Steve asked about the image repository for different architectures. Maybe others, you guys can help me understand what exactly, or maybe I didn't follow what his question about. Because from an edge node perspective, when the edge node configuration is clear, then it knows what to pull. Okay. And then I think the third one is about HA. Dijen, do you know if there are other comments we can write down?
Just one question about is there any special protocol between the edge controller and sync service on some higher level?
So between the edge node and the edge controller is, as I mentioned, is the regular HTTP or TCP connection.
Yeah, on the Cube bus level, but the controller and sync service are just using HTTP to communicate with each other, right?
Okay. Yeah, and is it maybe related to Dejan's question here? Is the idea that the sync service is essentially syncing that edge's slice of the Metastore, right? So if the Metastore is holding a branch of the tree for each node, that particular node's metadata gets synced to only that edge.
Yeah.
Is that the primary? That's the primary job of that arrow between the edge controller and the sync service.
Yeah, exactly. Yeah, and then it has some performance implication there too.
Hey, Cindy, what kind of workloads do you support on the edge? Is it just pods, or do you support other workload APIs?
Like deployments and replication controllers, right? That all would need a master and a scheduler type of control plane.
Right, exactly. So do you run any controllers at all at the edge, or it's just the kubelet making sure that the pod is running?
Just the lightweight kubelet.
Okay, so when how do you, so from the central plane, when you use kubectl to deploy workloads to the edge, like pods, how do you do like a spray, like when you create a pod, is there an object that replicates it on all the edges, or you target each edge one by one? And how do you?
Yeah, we target each one by one. So the Kubernetes scheduler would still do its thing, and then figure out which pod belongs to bind to which node, right? And
so
then
for targeting, you use labeling to make sure that the workloads land on a particular edge. Okay.
Yeah.
Right. Okay.
Yeah, any like Kubernetes scheduling mechanism can be extended on this based on this structure.
Okay, so I'm probably curious as to why you chose this design versus running a full controller on the edge, just for a lightweight.
You mean run the edge controller fully on the edge core?
Like running a Kubernetes API on the edge.
Oh, okay.
Resource, pretty much, right? Like it starts to get a lot to schedule, to do the API server and the scheduler and all the other control plane.
Okay.
Well, not only that, I think in this picture, there's one API server at the central, if I'm wrong.
Yeah.
And that means if the connection to the central is down, if you tried to run controllers, which would usually be demanding use of the API, they'd go down.
Fair enough.
So if I hear your question correctly, you're saying why not have a Kubernetes cluster locally on the edge, right?
No, I was just trying, yeah, that is correct. I was just trying to understand, had you looked at that
I
approach
think,
and then decided this?
yeah. So the mainly, I think from a very high level is how we view the edge cloud. We see this edge is a resource, is an extension of the cloud.
Right. Fair enough.
Yeah.
Right. So what is the order of, like, you're looking at order of 1,000 or order of 10,000 or like 100K edges supported by a single API?
So for that, well, we are currently doing the perf evaluation. I don't have the number yet.
Okay. 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 That's fine.
Okay. Yeah. Yeah, that's pretty much what I have. I think we can talk more, and then I would really like your feedbacks here. I think I heard about Steve and Preston mentioned about the storage using etcd or Q or SQLite. Can you help me understand what's the reason you asked that?
It's actually probably related to Barney's question on the scale of the number of nodes and whether or not that, because etcd is used so much for other key kind of cluster functions in the cloud, if there was at some point enough scaling out of the number of nodes that line between the edge controller and the Metastore could be removed to a different key value system to sort of preserve the load or function of etcd for other, control plane usages. And that's hypothetical. I'm not saying that would become an issue. I just think that's a potential area where you would want to divide the effort. But honestly, it could just be it's an independent etcd instance as well. It just sort of has to do with mixing the task on one etcd instance.
I think almost certainly when you look at people who've used etcd for collateral, that once you get a certain scale, it ends up being an independent etcd instance. And etcd, as it gets big, can have a pretty big appetite for resources itself, as well as low latency networking.
Okay,
but,
I see.
I mean, I suspect you did it with an abstraction layer such that etcd could be swapped out anyway. So maybe these don't matter. Anyway, that was a great presentation. And if you're going to be presenting at KubeCon China, I'll be there and love to learn more.
Okay, thank you.
Schedule some kind of a birds of a feather, open discussion meeting while we're there as well.
Yes. Yeah.
And I know there's legal and all sorts of process reasons, but if there is a way for some of us just in this working group to get a preview on GitHub, I know several of us would love to kind of answer more questions ourselves just by looking. Right,
yeah,
because
sure.
I have more questions, but I don't. I could probably answer them if I just looked at code rather than.
Okay, sounds good. I think for that I need to circulate back, and then I'll need to ask, and see.
I understand.
Yeah, maybe in the meantime we can use Slack and the forum we have to, discuss all the things interested to this topic.
Okay. Yeah. Great, thank you.
Thanks, Cindy. I also think this was great, and we ate up the whole hour for the meeting. So maybe I don't know what do you guys think? Maybe we can just leave it here for now.
Yeah, I'll just say that I'm sorry I had booked time to do the stuff I said I was going to do on the white paper, and that time on my calendar got. As you all are familiar with, sometimes things get bumped by other tired.
Yeah, sure.
I didn't get done what I was hoping to, so apologies, basically.
No worries. I plan to do more than I did, so basically, try for the next sprint, next 2 weeks to get the document more in shape is what's on my list.
Is any of you attending the Mac Congress in Berlin next week? It's the Etsy Mac Congress.
Not me.
No.
No.
Cool. Thanks.
Okay.
Okay. Yeah, so let's continue chatting online until the next meeting.